This is Greg Troutwine with Maritime Reporter TV, and we're very pleased to be joined today by Martin Meyer, the Global Product Manager, Gas Monitoring Software for ESAB. And we're here specifically to talk about FloCloud, which is a gas monitoring hardware and software solution from InduSuite, ESAB's portfolio of software solutions. So, Martin, truly a pleasure to have you here today. Um, can you just, to start us off, can you just discuss where gas is used in shipyards and why gas monitoring specifically is important?
Thank you, Craig. A pleasure to be here. So it's quite an easy answer, but it's also not an easy answer because you can have gas sources or gas consumption throughout the whole production in a shipyard. We are focusing right now on the welding part of the production. So any kind of welding machine throughout the production, manual machine, to some extent, it's a robotic system or a cobotic system. So you can have any kind of gas consumption throughout the welding production, but then also in some kind of laboratories or also additionally cutting that uses a lot of gas. Basically, any machine that is consuming gas is a potential kind of like, customer, so to say, for us.
Why don't you discuss what exactly does FloCloud do?
Yeah, so FloCloud is basically the software side of this application that is analyzing any kind of gas consumption, gas flow, pressure, so different kind of metrics and parameters that are connected to the gas usage and gas consumption in the production. And we are getting these parameters and metrics from different kind of sensors that we would install on the gas consumer or the machine, whoever is using the gas. So to summarize this, it's a solution that monitors and captures your gas parameters in regards to consumption, pressure, fill level, and any kind of metrics that you could imagine for gas usage. So generally speaking, there's a lot of manual work involved. A lot of different kind of Excel sheets or even like manual tables that are filled out from the service department that are manually going around the shipyard, checking each and every machine, which is obviously a lot of time that they need to spend on these kind of work and efforts. So throughout the different kind of companies that we are working with, this is kind of like the state of the art, what they are doing.
So can you run us through some scenarios for leak detection and overconsumption in welding operations? Because I'm sure that might be prevalent, particularly when they're not monitoring the situation.
So I have prepared 2 examples for you to showcase you some numbers and explain a little bit how we did these approaches at those customers. So in this first example here, we initiated a trial together with the customer on 4 different machines. Right away, when we installed our system on 2 of those machines, we were detecting a leakage. So there was a constant flow of gas out in the atmosphere. Basically, you buy the gas, it's leaking somewhere, and then you're losing it out into the atmosphere. So basically calculating the average of those 2 machines for the 4 we have, we were ending up with a value of 5 liters per minute of leakage. Then we did together with the customer a little bit of calculation. So in this table on the left side, you see the number of units that you could potentially attach our sensors to. And on the top, you can see different kind of values that a customer potentially pays per cubic meter of gas. So in this example that we see in the green one in the middle, where we have 100 machines at a cost of 0.4 euros per cubic meter, we end up in a loss of a little bit over 100,000 euros per year just in the leakages. And then on the second example, for the overconsumption, this was also together with a customer, a trial. In this trial in particular, we also measured the arc time with our WeldCloud system, and this helped us to later on compare the targeted consumption values and the actual measured consumption values. So you see there is 2 different columns, one calculated for 7 days and one for 300 days. And on those graphs, basically, you see a target consumption on the left side and the actual consumption then, which resulted in the first station of a saving of 23%, and on the second station at a savings of roughly 20%. Just by reducing the overconsumption of measured roughly 27 liters per minute to the target of 23 liters per minute.
When you can tangibly show them, when you can share numbers and information, that is so much more impactful than just saying, hey, we're going to save you some gas, we're going to save you some money. So I guess the next question would be, could you show us how the FloCloud system works?
Yes, of course, certainly. Before we do that, I would like to show you this mobile kit or mobile rack that we have built, because we will see this exact piece here in the software itself. So this is kind of like just a basic splitter where we have our sensors connected. So you will connect a single gas cylinder on one side, and then you have two outlet points on the other side where you can actually physically connect your welding machine. And in this rack itself, you have sensors like this. This, for example, would be our flow sensor. One hose in, one hose out, super easy to connect, and then you're good to go to start measuring your parameters. So how this will look like in the software, quite easy. So here in this case, we have our digital gas system. And as I said, this is our digital recreation of the physical world. On the left side, we have our gas cylinder connected with the primary regulator that has a high pressure and a low pressure sensor. We have a splitter here in the middle, one going in, three going out, and then connected our two flow sensors. And at the end, we have our two welding machines. Here on the primary regulator, we can see right away the high pressure that we are measuring right now at 107 bar and the low pressure at around 5.6 bar. This whole setup is super easy to make. In this case, I can show you how we can edit our splitter here in the middle. So let's take this one out and we just add a new one. One in this case, we will put two out. And then all you need to do is connect the dots. And this is how you would create your gas system. So this is kind of like the heart or the brain of the whole software. This is what you need to do first. And then once you set up your notifications, you will see here, for example, this welding machine is sending us a notification. If we click on this issue, we will see there's a low flow in the outlet point. So this could then basically mean a leakage that we are detecting here. Or in this case, as this is a welding machine, we then see that our gas flow parameter is too low. So the welding quality is at risk. So potentially we could create porosity here with this low gas flow. So built on this gas system that we have created, as I mentioned, we can set up different kind of notifications for each and every parameter that we measure. If it's the pressure, the fill level of the gas cylinder, or as I showed you, the gas flow value itself, all notifications can be sent to the user automatically via email or in the software itself. So whenever something happens in our gas distribution system, we get the information right away and can take actions immediately before we are losing gas, which means we are also losing money, or potentially one of our workers is at risk because of a gas leakage.
How do you go about working with shipyards?
Yeah, well, with shipyards, it's always a different kind of work, as they are like having or a special industry, or the way they work is special compared to other welding industries or welding production. So you need to be very flexible, of course, as every shipyard is kind of like different compared to the other one. And this flexibility is really what helps us with ESAB and our partner GCE together, as we have a lot of experience with different kind of shipyards and also have a lot of different products in our portfolio that can help us also after we implemented the system like FloCloud.
You know, all shipyards are different. You know that all what they're building, how they're building, and sometimes they're maybe hesitant to invest in new technologies. But I think when they see that return on investment, that really pulls the trigger because everybody wants to be more efficient and effective in their work. So, can you provide some real world examples of savings for shipyards? And I know it's difficult to say exactly what the ROI would be, but generally, what can they expect in terms of return on investment?
Yeah, so the return on investment, there are multiple ways and factors that come into that. First of all, and we already touched on that, would be a leakage detection, which is directly going into the ROI if you eliminate leakages. But second would be overconsumption, which we see a lot in different kind of shipyards. So here in this example, we have here gathered data based on WPS or welding procedure limits that we have set. In this case, the welder should work somewhere between 14 to 20 liters per minute. As we see here, this welder was perfectly in line with those limits, but over or under consumption would be then shown here in those red and orange colored areas. Welders, they have often, or most of the times, they have a mentality like more is better. So they turn up the gas flow as much as possible, and then we would see the actual measured gas flow somewhere in the red area, which is outside of the welding procedure specification limit. And by this, we would then also get a notification. Of course, this is in regards to quality, but also overconsumption, reducing in a lot of additional costs, which don't give you additional benefits. So all of these kind of metrics that we measure and that we analyze directly impact the ROI. That's why we do exact calculations of the ROI together with each and every customer to get an accurate and exact number for them.